All right, today we are diving into something really, really cool, OPHI City. Now, this is not just another virtual world or some new video game. No, this is an entire digital reality being built from the ground up. And get this, it has its own uncheatable laws of physics. Let's dig in and see how on earth they're pulling this off. So, the creators call it an omega-governed semantic simulation engine. Okay, that sounds like a massive mouthful, I know, but it points to this really deep fundamental order that's built into the system. And you'll see these strange glyphs pop up, like the ones for creation and fossil lock. And these aren't just for decoration, they are literally part of the world's core law. It's like the DNA of this digital universe. So that really brings us to the central question of this entire project, doesn't it? I mean, how do you actually build a digital world that doesn't just have suggestions or rules, but has laws? Laws that can't be broken, can't be hacked, can't be glitched around. How do you create a simulation that has genuine, truly enforceable physics? To even begin to answer that, we have to start with the rules themselves. You know how most virtual worlds can just descend into chaos? Well, OPHI City Solution is a set of fundamental principles that govern every single thing that happens inside it. These are its absolute, non-negotiable laws of reality. The very first rule is all about fighting chaos. In OPHI City, they call this chaos entropy. You can think of it as a measure of randomness or just plain nonsense. If the entropy in one part of the world gets too high, that area literally starts to lose its meaning. It just falls apart. The force that pushes back against entropy is coherence. This is the measure of order, of consistency. Coherence is kind of like the cosmic glue that makes sure everything makes sense according to the world's own logic. It's what keeps the whole simulation from turning into a jumbled, meaningless mess. And then there's this third, more subtle force called drift. This is the tendency for the simulation to slowly, almost invisibly, become inconsistent with itself over time. It's a measure of instability, like a slow-motion decay of the world's integrity that has to be constantly kept in check. And here's the kicker. These aren't just vague concepts. They are hard-coded numbers, as you can see right here. Coherence has to stay at or above 0.985. Entropy cannot, under any circumstances, go above 0.01. And drift must be kept below 0.0001. These numbers are basically the fundamental constants of this digital universe. So how are those laws enforced? Well, this slide shows you exactly how. This little piece of code is called the SE44 governance gate. You can think of it as the ultimate bouncer for reality. Before any new piece of the world is even allowed to exist, its metrics for entropy, coherence, and drift are fed into this function. If it doesn't meet those exact thresholds, it's rejected. It's not allowed in. Simple, brutal, and effective. Okay, so with those rules in place, how is the world actually built? It's not like it's created all at once. Instead, it's assembled, piece by piece, under the constant, watchful eye of that SE44 gate we just talked about. Let's take a look at how that whole process works. The process is called governed streaming, and it's pretty straightforward. First, a new sector, just think of it as a chunk of the world, is proposed. Then its semantic values, entropy and all that, are calculated. After that, those values get passed to the SE44 gate for a simple yes or no check. If it passes, boom, it becomes a permanent part of the world. If it fails, it gets thrown out, as if it never even existed. Every single digital Lego brick has to go through this exact same test. The source code structure itself tells this story beautifully. On the left, in the engine directory, you've got the machinery. The world streamer, the physics, the ledger. This is the stuff that actually builds reality. And then on the right, in the semantics directory, you have the rulebook, the code that defines entropy, coherence, drift, and the SE44 gate itself. The machinery must always, always obey the rulebook. But here's the thing. Just having rules isn't quite enough. You also need to be able to prove they were followed every single time without exception. And this brings us to the next absolutely crucial component, a permanent, unchangeable history of the world that they call the fossil record. Which, of course, brings up another fascinating question. How do you build an indestructible black box for a digital universe? I mean, you need more than just a save file. You need a completely tamper-proof audit trail for the entire history of the simulation, one that proves it has never, ever broken its own laws. And the answer to that is the fossil ledger. The critical detail is right here in the code, inside this attempt record function. Before it even thinks about saving a snapshot of a world sector, it runs that sector's data through the S44 gate. Only states that pass the governance check are actually recorded. This makes sure that the history itself is pure and has never, ever contained an illegal state. So why does this matter so much? Well, it allows for a perfectly repeatable, deterministic history. It means that other systems can actually audit the world and verify its integrity from the outside. You can build perfect replay systems. It creates a trusted, versioned history of the simulation's entire evolution. It's basically the ultimate proof that the world is what it says it is. Now, a system this complex isn't just built in a day and then left alone. Not at all. The project documentation shows that OPHI City is a living, breathing project. It's constantly being refined and improved by its creators to make it more robust, more consistent, and just better. Here's a great practical example. At first, the player movement was kind of flawed. Because of how the math was done, you could actually move faster diagonally than you could forwards. The aftercode shows the fix. They normalize the direction vector. This makes sure movement speed is perfectly consistent no matter which way you're headed. It's a small change, but it's absolutely vital for a consistent world. Another really cool upgrade was something they called the semantic atmosphere. At first, the visuals would just abruptly change color based on these hard thresholds for entropy or coherence. It was a bit jarring. The new system, on the right, creates this beautiful, smooth gradient. Now, the color of the world continuously and subtly shifts to reflect the underlying state of things, making it a much richer and more intuitive experience. And this integrity review checklist really just summarizes that whole journey. You can literally see them ticking off the fixes, wiring up the drift parameter, timestamping the fossil records, stabilizing movement, and smoothing out the atmosphere. This is the list of steps that took OPHI City from just a theoretical framework to a fully operational, governed runtime. Okay, so let's pull all these different threads together. We've got the rules of reality, we've got the gatekeeper that enforces them, and we've got a perfect historical record. What has actually been created here? What does this all mean? The key takeaway is this. OPHI City is not just another 3D environment. It's a deterministic universe. The combination of that rulebook, the SE44 gate, and the history book, the fossil ledger, creates something fundamentally new. It's a digital reality with its own provable, auditable laws of physics. And that leaves us with one final, pretty mind-bending question. We've seen the blueprint for how to build a small, contained digital universe with rules that can be proven to have been followed. So if that's possible, what comes next? What are the bigger implications of creating truly governed, truly verifiable digital realities? Definitely something to think about. Thanks for tuning in.